Good morning, students. I am Dr. B.N.Jha from Mohali Devi Memorial School. And today I would like to take the classes of class 12. And in this class, I would like to discuss sexual reproduction. In our previous video, I had taken asexual reproduction and that part is already completed. Today, I will discuss the sexual reproduction in organisms. Wherever it is needed, then I would like to discuss the specific point like the sexual reproduction in plants or animals one by one. But in this session, present session, first I would like to discuss sexual reproduction as a whole, and then I will try my level best to discuss sexual reproduction in plants. So let us first discuss sexual reproduction in organisms. There are a diverse forms of organisms, starting from unicellular organism to multicellular organisms. These organisms, on the basis of their status, their rank in evolution, they have adapted themselves for different types of reproduction, as the reproduction is the only way to maintain the continuity of the life over the earth. And different organisms, they have adapted themselves to choose the mode of reproduction. In the previous session, I have already stated that these mode of reproduction are asexual and sexual reproduction. Asexual reproduction is already completed. Today, sexual reproduction we are discussing here. Sexual reproduction is performed by a majority of organisms, whether it is plant or animals. But most of the primitive organisms, the plants, and you can say the fungoid plants, those plants which are not very much differentiated into root, stem, and leaf. These, some of them, they exhibit sexual reproduction. Likewise, the bryophytes, they also exhibit sexual reproduction. Then pterophyta, gymnosperm, angiosperm, sexual reproduction are there. What about animals? In animals also, sexual reproduction is exhibited, and not only exhibited in full swing. Sexual reproduction now is a reproduction in which two sexes are involved. Here, two sexes means male sex as well as the female sex, and they produce their specialized cells. These cells are called gametes, And these gametes fuse together to form a new cell composite that is called zygote. There is the fusion of whole cell, means the nucleus as well as the cytoplasm. This is in another word you can say this is mingling of chromosome. So this fusion takes place, that is called fertilization, and the product of the fertilization is zygote, and from zygote a new organism again develops. This is the, in short, the sexual reproduction and the process of sexual reproduction. Now, this sexual reproduction, when we go and see in lower organisms, means who are very primitive in point of view of the evolution, in them this is sexual reproduction or the sexuality is very much confused on the basis of sexes. The organisms are not very much different from one another. Means it is unrecognizable which one is male and which one is female. But when we go further in developed organisms, male and female organisms are very much clear-cut, differentiated from each other. So before going in discussing of all these things, I would like to tell you what are those events in the sexual reproduction which we are going to discuss here. So these are pre-fertilization events, then fertilization, that is fusion of gametes, and then post-fertilization events. So one by one we will see these events, how it continues. Pre-fertilization events. Pre-fertilization is before fertilization. What are the preparations in sexual reproduction? The first thing is preparation of those cells which are going to fuse and make a zygote. So these cells, specialized cells, are called gametes. So formation of gametes is the first requirement of fertilization. And since it takes place before fertilization, that is why we are discussing here. The pre-fertilization means the formation of gametes, and that is called gametogenesis. Gametogenesis. These gametes are produced in different organisms in different ways. In the plants, the gamete producing organ can be said as B.N.Jha. The special name of these B.N.Jha may be different. But as a whole, this is called gametary. Male gametangea, female gametangea. So this gametogenesis is one of the important part in which gamete is being formed. Most of the gametes are haploid in nature. Haploid means the number of chromosomes becomes half in this process. Means from the diploid condition, it becomes a haploid. You must be knowing what is the diploid condition. This is called 2N. N is the one set of chromosome, and when 2N means the same set is doubled, then it is called 2. In our another video, we will discuss it in detail. What is the meaning of 2N, normal, and N? But taking one example of human being, you just think we have 46 number of chromosomes. But out of these 46, only 23 types of chromosomes are present. 23 types means each and every type of chromosome has its exact copy of it. Means 23 type and another 23 type. They make 46. That is why it is called 23 pairs. So this 23 is called one set. And this one set is M. You think like that. And when two such sets are there, it becomes 2N means 43. 46, sorry, 46 means 23 plus 23 and plus 2. This condition having in is called haploid, and 2N condition is diploid. We will discuss the ploidy in another class, and here we are going to discuss the gametogenesis. So during the process of gametogenesis, a cell division takes place, that is called meiosis. And due to this meiosis, one mother cell divides into 4 daughter cells, and these daughter cells are haploid in nature. Means mother cell is 2N, then 4 daughter cells. Out of these 4 daughter cells, each and every will have only N number of chromosomes, means just a half. And the gametes which are going to be formed during gametogenesis, these gametes contain N number of chromosomes in it, and so they are called haploid. So in most of the cases, gametes are haploid in nature, and this gametogenesis is the process of formation of gametes. So basically, what is gametogenesis? Gametogenesis is the process of meiosis, cell division, meiosis. And due to this meiotic division, gametes are formed. Now, gamete is formed, different organisms have different types of gametes. It is very clear that gametes are formed in the gametophysia, and special names for gametophysia may be there. In the later stage, we'll see one by one. But gametes are of different types. When we talk about the gametes produced in lower plants, they are either motile or non-motile also. They are similar in structure, shape, and size. May not be. So, on the basis of occurrence of different types of gametes, we have termed them as different. So, in lower plants, gametes are produced by different strains, means male and female plant body, but they are not distinguishable, means they are not recognized which one is male and which one is female. They have pleasure in them. These are pleasure, means motile. When we see it from outside, it looks the same. But since they take part in fusion, so it is certainly of different origin, means one from male and another from female. In this case, these gametes are called isogametes, similar gametes. The gametes are of similar type. Since they take part in fusion, that is why we understand, we recognize that one is male and another is female, but it is not very clear to tell which one is male and which one is female. Only we can say they are of different strains. Sometimes we used to put like that plus and minus signs, or simply one is male and another is female. Which one is male and which one is female is not clear. So in those cases, these gametes are called isogametes. Some gametes in the developed or higher plants and animals, these gametes are produced by different organisms, means male and female, and they have different shape and size. Like taking one example of human being, a sperm. This is male gamete. For mobility, it has a tail. It can move. Size is smaller in comparison to the ovum. Ovum is non-motile and bigger in size. It moves. So these gametes take part in fusion and form in zygote, but they are different in shape and size. That is why they are called anisogametes. These anisogametes can also be said as heterogenes. This is the case of higher animals, evolved animals, developed animals. Here I would like to mention one thing. In the case of bryophytes, these gametes are formed in a specialized B.N.Jha. They are called B.N.Jha archegonia. In these, in the antheridia, which is male sex organ of bipeds, they produce antherizoids. These antherizoids are male gametes. And they are motile. They move from antheridia to archegonia. Archegonia is the female part and it produces ovum. It is non-motile and kept in lower part of the archegonium, and the antherizoids, it moves through the tube in the archegonium and meets to the ovum and fertilization takes place. So this is the case of the bryophyta. Here we are discussing about the different types of gametes is possible in different organisms. Second thing is, gametegenesis is completed then. How to transfer the gametes from one place to another place? Means for the fusion, unless these different gametes, means male gamete and female gametes, come together and then fuse, then what is the formation of gametegenesis? I mean, what is the gamete? Means they have to go from one place to another place. If they are isogametes and they are motile, they are generally produced in aquatic environment. That is why in the water they move and meet together, fuse together. What about in other organisms? In the angiosperm plants and in the developed evolved animals. So what happens? So there are so many means of transfer of gamete from one place to another place. Water is very important medium through which these gametes are transferred from one place to another place, in the especially in the aquatic organisms. Not only the aquatic organisms, but the amphibian organisms also. Amphibian, the bryophytes, are called the amphibia of the plant kingdom. In the bryozoans also, water is very, very important medium for the transfer of gametes. But when we move to the angiosperms, gymnosperms, then there are so many agencies for the transfer of gametes from one place to another place, especially the male gametes. This can be achieved by water or wind or insects or bigger animals. When we will discuss the transfer of gametes in detail, this is called pollination, and we will have different names for these things. When pollination takes place through water, this is called hydrophily, anemophily, entomophily, sorry, aerophily, by air. So, different names of the process of pollination is there, but here we are here to how these gametes are transferred from one place to another place. So, this is the transfer. In the animals, how transfer of gametes takes place from one place to another place? We can categorize it. This transfer of gametes is the process of fertilization. So this can be brought about in different ways. Male gamete moves to the tract of the female body, and then it meets to the egg, and then fusion takes place. This part is fertilization, but before that, this is transfer. Transfer means how it transfers. So in the fertilization part, we will discuss how fertilization takes place one by one. Pre-fertilization means we have seen basically gamete formation, gametogenesis, then is transfer of gametes from one place to another place. Now comes to the fertilization process. What is fertilization? Fertilization is simply meeting of male gamete with the female gamete, or meeting means fusion of male gamete with the female gamete. Fusion of gamete, male gamete with the female gamete forming zygote. This is called fertilization. The fertilization contains different associated activities. Means before actual fertilization, during the fertilization. So these all are called fertilization. Just now means fusion of male gamete with female gamete forming zygote. This is called fertilization. But the actual fusion of male gamete with the female gamete in totality. Totality means the fusion of nucleus and the fusion of cytoplasm. Then fusion is completed, otherwise not. When fusion takes place, fusion of nucleus took place and fusion of cytoplasm is not taking place. Or fusion of cytoplasm takes place and fusion of nucleus is not completed. Then this fusion is not completed. I would like to tell you, fusion means when fusion of cytoplasm as well as the nucleus is completed and it converts into a new cell that has only one nucleus, in which the chromosomes of male gamete as well as chromosomes of female gamete are mingled. This new structure is called zygote. When zygote is formed, then fusion is completed. So this is complete fusion, and this complete fusion is called syngamy. Syngamy. So fertilization, in other words, we can understand syngamy also. But when we talk about different types of organisms, plants, animals, and in the sense of sexuality, we will see different types of organisms are there in one species, like human being, like other mammals, when and other lower animals also, when we see in the same species, two organisms are found. But these two organisms are differentiated, can be differentiated from one organism to another organism on the basis of sex organs and the characteristic features, sexual characteristic features, that is called sexual features present on them. That is why this is called dimorphism. Means two morphology on the basis of when sexual organism, sexual features, this is called sexual dimorphism. But in many of the species, this sexual dimorphism is not found. In plants, when we talk about some plants are such their flower bear only one sex. Those plants are called, those flowers are called unisex. Unisexual flowers. Means the gametes are produced for the fusion from two different individuals, two different flowers, and this condition is called dioecious. But some plants are also there in which their flower contains both of the sex organs. Then this is called bisexual flowers. And this condition is called monoecious. Monoecious means unisexual and bisexual flowers are present. Here we are talking about the fertilization or syngamy So what happens in syngamy? Fusion of male gamete with the female gamete. But this syngamy can also be of different types. Means endogamy or exogamy. What do you mean by endogamy? When we are talking about the bisexual flowers, in the bisexual flowers, pollination means transfer of pollen grains from anther to stigma. This is transfer of gametes. So when the transfer of gametes, means male gametes, to the female gamete takes place in the bisexual flowers in the same flower, means the male gamete of the same flower is transferred to the female gamete or to the part of the female body of the same flower without the involvement of any agency. This is called self-pollination. And due to the self-pollination, when fusion of these two gametes is attained, such type of fusion of male gamete with female gamete is called endogamy. It's called endogamy. But if the flower is unisexual, in that case, fusion of one gamete with the female gamete takes place, and the origin of these gametes are different. So in that case, this is called exogamy. Like the human being is the example. The syngamy in the human being is like exogamy. So this is the fusion, means fertilization, syngamy. So what happened? There are so many examples in the sexual reproduction. There are special examples where new organisms develop without the involvement of fusion. Means fusion of male gamete with the female gamete. Means no syngamy is attained, but the new organisms develop. This type of activity in the nature is called parthenogenesis. This parthenogenesis means the egg is there, and from the egg new individual will develop, but before that it will be fertilized by male gamete. But here in the case of parthenogenesis, no fertilization takes place. Egg is born, it matures, and without any fertilization, new individual develops from the unfertilized egg. Unfertilized eggs. This is a very miraculous activity, takes place in nature, and it has many beneficial aspects. When we are talking about bees, honeybee, you must be knowing in a honeycomb there are so many honeybee, and categorically they are in three: queen bee, it remains in the honeycomb, and this is only for laying eggs. Then another is drone. Drones are males. And third is workers. They work for, they are busy in collecting the honey from different flowers and depositing in honeycomb. Here, these are developed from unfertilized eggs, especially the drones, unfertilized. Workers of. So, in aphids also. So, there are so many examples of parthenogenesis in which without fusion or syngamy, new organisms develop. This is called parthenogenesis. This parthenogenesis may be natural or unnatural. Natural when it takes place in nature. This is natural. Just now I told. But in a unnatural condition, means artificial condition, we people give some extra stimulus in the form of irradiance or in the form of chemical substances. Due to this stimulus, the unfertilized egg develops into the new organisms. So this is called parthenogenesis. Now, post-fertilization events. What happens when fertilization is completed? Fertilization when is completed, then zygote is formed. Then this is the diploid condition 2n. It maintains the ploidy of the parents and new organisms develop. So, what is the process of developing of new organisms from zygote? This is called embryogenesis. Means after the repeated cell division, this zygote is converted into embryo, and then again cell division takes place, differentiation takes place, and this this process is called embryogenesis. Means in the sexual reproduction. Similarly, in asexual reproduction, I will forget it. In asexual reproduction, the development of a new organism from any sprout or any potential birds, this is called blastogenesis. Asexual reproduction. But here, this is called embryogenesis. And due to the embryogenesis, what happens? Sexual reproduction is completed, embryos are formed, then further development of embryos are formed. So, how further development takes place? So, here I would like to discuss from the fertilization part, then it is better to understand. Fertilization is of different types. When fertilization takes place inside the body, this is called internal fertilization. That takes place in the case of human beings, in other organisms also. Means the fertilization means the transfer of male gamete is completed in the body of the female, and then it travels due to the some locomotory organ in the sperm to the level of the ovum or egg, and fusion takes place. So this is called internal fertilization. Some fertilizers are external. External fertilization means the fusion of male gamete and female gamete takes place outside the body. In the internal fertilization, it is completely inside the body, and development for the development of the embryos and the baby takes place inside the body, and after the completion of the incubation period, this comes out of the body. That's called taking birth or parturition. Here in this case of external fertilization, gametes are shed outside the body, maybe in water, as frogs does. Frogs, in the case of frogs, they come in the aquatic environment, and they shed the male gamete as well as the female gamete at the same time, same place. In water happens, fertilization takes place, in gamete takes place, and further development takes place in the water. So this is external fertilization, mean outside the body in the external environment, and development of the embryo is also external. It takes place. One thing here is notable. Here in the external fertilizing cases, number of gametes or male and female gametes are produced in plenty. Why? Because there is a fear of destroying the gametes by the predators. That is why to maintain the continuity of the species over the earth, it is very necessary to produce a large number of gametes so that at least after eating up by the predators, some of them must be there or must develop into new organisms. This is external fertilization. In the case of internal fertilization, when we talk about the lizards, the birds, development takes place outside the body. One thing one can say, internal fertilization takes place and development also takes place inside the body, like the human beings, cows, buffaloes, dogs. And in the case of birds and lizards, internal fertilization takes place, but further development takes place outside the body. And so, since outside in environment it may be destroyed, that's why it needs protection. And for the protection point of view, a hard calcareous outside of the cell develops calcareous plate, calcareous sheet develops that protects the cell so that inside the calcareous cell it may develop into the new organism. That happens generally in the case of the birds and lizards. But in the external fertilization, no such type of protective layer is there, but the protective layer is there. Some gelatinous substances are there which can protect the zygotes and the embryos. So this is case of the fertilization as well as the development. Here I would like to mention two words, oviparous and viviparous. When we are talking about the giving birth, means development of the embryo inside the body and taking birth of the newborn baby in the form of just like the parent one, means in the form of flesh and bones. Such type of animals are called viviparous. But in the case of just now I told you, birds and lizards, fertilization takes place inside the body, gamete takes place inside the body, and further development takes place outside the body after covering that cell by the hard calcareous sheet, the egg cell, and it gives birth. Birds and lizards, they give birth the egg. Such type of animals are called oviparous. So, on the basis of the giving birth to the new one, means baby, as well as egg, different types of organisms can be set on the basis of that, like viviparous and oviparous. So this process is called vivipary as well as ovipary. Now, I would like to discuss the sexual reproduction, especially in plants. You people must be knowing the flower in the plant is the sexual part. Or in other words, you can say the flower contains the sexual part of the plant. What is flower? Flower is the modified shoot. When we talking about shoot, what do you mean by shoot? Shoot means the above ground part of the plant is called shoot. It contains different nodes as well as internodes. And from nodes, leaves are developed. We just think about what will happen if it is compressed from both the ends. If it is compressed, then it will be like the flattened one. It may be like this. Maybe the nodes like this. This is internode, this is nodes. Suppose this becomes like that, this becomes like that, this becomes like that. Nodes and internodes. Suppose if these plants or leaves which are present in the at the nodes, they are modified and their purpose is changed to produce different things. So they are called modified. What depends actually in plants, this is the reality. These leaves modify this, the axis, central axis, or you can say the inflorescence, the central axis, they get modified and they look like that, and these modify in different parts. So different parts of the flower are the modified leaf, you can say. Modification of shoot. So when we talk about the different parts of the flower, you see these are the modified leaves. They are situated over the nodes, and in between the internodes are there. Here in the case of the flower, the internodes are very, very compressed. That is why the modified leaves are seen arranged very nearly together. Thank you. Now, these flowers have 4 words. walls. What do you mean the walls? They are arranged, four things are arranged in this circle. Outermost circle is the calyx, then is corolla, then is androecium, and then is gynoecium. Calyx is the green part of the flower, which is the outermost part. Then comes inside the calyx is the colorful part that is called corolla. This may have fragrance also, different bright colors also. This corolla. There is androecium, the male reproductive part, and then comes in the center gynoecium. This is the female reproductive part. One unit of calyx is called sepal. One unit of corolla is called petal. One individual male representative of the androecium is called stamen. And one individual representative of the gynoecium is called carpel. Or you can say carpel is also called pistil. In some of the plants, this calyx and corolla, they are not separated. Only one type of color and appendages are there. Means they combine with each other, and in that case, this is called perianth. Perianth. And one unit of perianth is called sepal. Sepal. So what is important here in the case of flower? If calyx or corolla is not there in the flower or they are removed, then also sexual reproduction will take place or not? Certainly, sexual reproduction takes place. Why? Because androecium and gynoecium are that two parts still there in the flower which can carry out the sexual reproduction. That is why these two, calyx and corolla, are the non-essential wall of the plant, while these two, androecium and gynoecium, are called the essential wall of the plant. Essential. Essential. Here we are talking about the androecium and gynoecium, means the stamen and partial. So, how development of the stamen and partial takes place? Stamen. Stamen is slender, this It has two parts. This head part is called anther, and this long over which anther is suspended, this is called stalk. This during the course of development, it develops in the flower. These anther is just now looks like bilobe. Bilobe means two lobes are there. Two lobes. But each lobe contains two chambers or sacs. So, as a whole, there are in total 4 chambers. So, in the case of anther, we can say maybe bilobe or 4 chambers. These two lobes are differentiated from each other by means of tissues that is called connectives. Connectives. For the supply of nutrition and other things, these anther have only one vascular bundle in the connectives, and from there only these supply are there. Vascular bundle. These are 4 chambers. These chambers, since in these chambers, pollen grains are developed. That's why they are called pollen chambers. Initially, what happens? In the earlier condition, the anther is of only the external wall that is called epidermis. This and this is the internal tissue actively meristematic means active station. These active meristematic tissue later on converts into the archisporium at the corners. These tissues are now called archisporium or archisporium tissue. Later on, in the course of development, what happens? In the archisporial tissue, at the corners at the corners especially. They differentiate into by the pericranial division into two layers, the primary parietal layer parietal layer and the primary sporogenous tissue. Primary parietal tissue and primary sporogenous tissue. Now, remember this is epidermis. Now, this epidermis, below the epidermis, this is primary parietal layer. At the corners only. And this is primary sporogenous layer. And again, in the primary parietal layer, pericranial division, anticranial division takes place. And also in the primary sporogenous tissues, so many active cell division takes place. And it converts into the sporogenous mother cells, from where the pollen grains will emerge or will be developed. So, primary parietal layer divides anticlinally, periclinally, and hence, in this way, organization of pollen sacs comes in existence. So, when we talk about the matured pollen sacs, or you can say the anther. So we will have from top to the center as follows. Epidermis, then next wall is called endothecium. Endothecium. Then 2-3 layer of wall layer. And the innermost wall is called tapetum. This is very important wall layer as it provides the nutrition for the developing pollen grains. There are so many activities are there in the process of development of the pollen grains, and during this process these grains need different types of substances, nutrition, and also so many things which are deposited there, and these are all things are supplied by this capital layer. So this is very important nutrition point of view, not only the nutrition point of view and for different protection point of view also. And then the cells inside the this is sporogenous tissue. Sporogenous tissue means they will be converted into a spore mother cell. Now, what happens during the development of the sporogenous tissue? These some of the sporogenous tissue degenerate, and some of them they change little bit, and they become prepared to behave like the spore mother cell. So some of them degenerate and also help those cells which are converting into the spore mother cell. Now these are called spore mother cell. Now what happens? This is the development of the anther, but from the spore mother cell, this is called B.N.Jha also. This pollen site is can be said as the sporangium also. So spores will be developed, means the pollen grains will be developed. Since it is very microbial in nature, minute in nature, so these are called microspores also. So development of microspores from the spore mother cell in the pollen cell is called microsporogenesis. So now we'll see what is the microsporogenesis. Don't forget these anthers or the carpels, they are modified leaves. They are also modified leaves, and since they are going to produce the microspore, that is why these leaves, modified leaves, are also called microsporophylls. Microsporophylls, modified leaves, which are going to produce microspores. Microsporogenesis. When a spore mother cell prepares cell to behave like a spore mother cell, means mother which will give birth to the pollen grains. Certain changes take place, and here In the spore mother cell, meiotic division takes place. Meiosis or meiotic division. Due to this meiotic division, what happens? One cell is converted into 4 daughter cells. This meiosis 1 and this meiosis 2. In the meiosis 1, the number of chromosomes becomes half. If it is 2m, then it becomes m. And in the meiosis 2, it is just like the mitosis or mitotic division. So here in the meiosis 2, the number of chromosomes is kept same in n. So as a whole, these are the daughter cells and they are haploid in nature, n, while mother cell is 2n. So haploid cells are formed. Now these cells are called as gamete. And due to this meiosis, haploid gametes are means micro gametes are produced. Microgametes here are called pollen grains. Microgametes, male gametes. Or male gametes, you can't see here male gametes. Actually, microgametes is better to say, and pollen grains. Pollen grains. So since due to the meiosis, one cell divides into 4 and they tend to remain together. So this is called tetrad. So pollen tetrad is formed. These in the pollen tetrads, what happens? The pollens are pollen grains, means 4 pollen grains are arranged in different way, linear, or decussate, or T-set. In different orientation, this is T-set. In the pollen tetrad. Now, come to the pollen grains. This is pollen grains. This is a rod structure. The wall of the pollen grain can be divided into two. Examine the upper wall, the inner wall in time. Examine can also be divided into two. Section and next sign. Section again. Two. Endo section. Tectum. This is upper. This is lower. In the section. Next side is again and next side and foot body. So when we arrange these four walls, so it will come like that. How? Number one, tectum, outermost. Below the tectum, endosection. Below the endosection is the endosection, and below the endosection is the foot body. Like this. This is the case of exine. The wall of the exine is secreted by capital layer, and it is the material. In nature, it is resistant. It is heat resistant, drought resistant, fire resistant, resistant for all. Means nothing there, neither the environmental condition, extreme environmental condition, nor the chemical substances, very hot AC or others, can wither the superficial layer, means enzyme of the pollen grains, because it is made of a special type of chemical substances that is called sporopollenin. This sporopollenin is secreted by the capital layer of the pollen sac. Actually, capital layer, they produce the Lewis body. Lewis body. These Lewis bodies are covered by sporopollenin, and the exine contains the Lewis body. That is why sporopollenin spreads over the external layer, its exine, and it becomes very hard. While in time is made of spectrocellulose. The spectrocellulose in nature, but here the facility of the sporopollen in the sense of pollen grains is there that in the exine, the surface of the exine has the ornamentation. Ornamentation means different types of sculpture like graving appears on the basis of the species to species. This sculpture is specific as when it transfers from pollen, grains are transferred to the stigma during the pollination process. It is compatible for the stigma or not, it is recognized by the sculptural pattern of the exine. So it determines the compatibility also. If it is not compatible, then these pollen grains cannot germinate if it is wrongly pollinated. Means the pollination takes place at the wrong stage. So that this is also very, very important. In the exine only, in the dicotyledonous plants, some points are there where these depositions are minimum, and these points are called germ pore. Germ pore. Actually, these germ pores are the pore aperture through which pollen tube comes out when it is transferred to the stigma. Pollen tube means these that in time comes out in the form of tube. Actually, it comes out from the aperture that is called germ pore. At least 3 germ pores are found in dicotyledonous plants, and 1 germ pore is found in monocotyledonous plant. In the pollen grains, we are talking here the outer surface of the pollen grains. What about the inner surface? Means the internal pits. This initially is centrally located nucleus is there. This is the nucleus and very dense cytoplasm is here. But later on, small vacuoles appear. And these small vacuoles they reunite and make the bigger vacuole. And so the nucleus is pushed towards the periphery and the cytoplasm also. There is cytoplasm. This activity takes place when it is in situ, means in the pollen sac only. Later on, Gradually, this vacuole disappears and unequal mitosis takes place. Don't forget, in this condition, two mitotic division, mitosis 1 and mitosis 2, two mitotic division takes place. So, one mitosis 1 takes place, and due to this mitosis 1, a bigger cell is produced. This is vegetative cell, and a smaller cell is also produced. This is generative. Gradually, a special substances they come around the germinative cell that is called callus. This is the two cell structure. In approximately 70% of the angiospermic plant where the pollen grains are produced, the liberation of pollen grains from the anther to different parts means the liberation takes place in two cell structure. Two cell structure. In this. But in the 30% of second mitosis takes place in this generative cell, and two nucleus are produced, callus disappears, and in the vegetative cell, it seems that these cells are embedded. These two nucleus of generative cell and one nucleus vegetative nucleus. So this is called three-celled stage. This three-celled stage, it develops inside in 30% of the plant. In situ means in the cell, and then liberation takes place. But don't forget, 70% is the two-celled structure. This is the microspores, means the pollen grains, and this stage is called cell within cell. Means the generative cell is inside is floating in the bigger vegetative cell. Now, pollination through different means takes place, and it comes to the stigma. This is stigma, and this pollen grain. This is germ pore. This generative cell and this is sorry, this is generative cell and this is vegetative cell, vegetative nucleus. What happens at the germ core level? The entire this entire comes out. Comes out, piercing the tip of the germ core means that this is pollen tube. The pollen tube, the tip of the pollen tube has the strong hydrolytic enzymes, proteases. This they dissolve the cell's tissue and make its way towards the ovary. So what happens in this meantime? First, the nucleus of the generative cell comes, and the cytoplasm also comes in the pollen tube. And finally, this generative cell also migrates into the pollen tube. If the pollen grain is two-celled structure, then second mitosis takes place here at the junction, at the emergence site of the pollen tube. If it is three-celled structure like this, then these two generative nucleus they migrate into the pollen tube and this come inside the pollen tube. Gradually, this generative nucleus degenerates and some callous body they come to block the generative nucleus for the protection of the nucleus, and hence it gradually moves towards the ovule where the female gamete means the egg is waiting for the fusion of the male nucleus. So this part we'll see after completing the megasporogenesis. Today is the microsporogenesis, and in the next video we will see megasporogenesis and fertilization together. That is one double fertilization. So today in this session, up to that we'll see in the next class. Thank you very much.